Fresh snow has a sound. Not silence exactly, something softer than silence. It swallows footsteps, muffles traffic, turns the world into a room with thick walls. You look at it and it's almost blinding, pure, flat white in every direction. Then you pick up a chunk of ice from the same frozen lake, hold it up to the light, and it's invisible, completely clear, like glass, like nothing. Both made of the same thing, both frozen water, one white as paper, one clear as a window. Everyone grows up with snow. Most people have touched ice, but almost nobody stops to ask the obvious question out loud. How the hell does the same substance, frozen water, look completely different depending on its shape? If ice is clear, why isn't snow? If snow is white, why can't you see through a glacier? What is actually going on when light hits those two surfaces? Think about that for a second. Let's start with the obvious thing nobody notices. Snow isn't one thing. It looks like a uniform blanket, but zoom in even just a little, and it's a chaotic pile of tiny individual crystals, each one a miniature six-sided structure with flat faces, edges, and air gaps between them. Scientists started documenting individual snowflake shapes seriously in the 1800s, but it was Wilson Bentley, a Vermont farmer who spent decades photographing individual flakes starting in 1885, who first showed the world that no two were identical. What he couldn't fully explain at the time was why a pile of those beautiful transparent crystals turned into a wall of white. Ice is transparent because light enters it and passes straight through with very little interruption. The molecular structure is uniform enough that photons, packets of light, cruise right through without bouncing around. It's like driving down an empty highway, smooth, predictable. You arrive at the other side carrying all the information you started with. Snow is a completely different road. When light enters a snowpack, it immediately hits the surface of a crystal and bounces. Then it hits another crystal and bounces again, and again, and again, at every random angle, thousands of times in a fraction of a second. Each bounce redirects the light. White light contains every color of the visible spectrum, but because each bounce sends a little of everything in all directions equally, no single color gets filtered or absorbed. The full spectrum exits the snow roughly the same as it entered, and when you see the full spectrum reflected at you all at once, your brain reads that as white. Today, when you look at a snowy field and squint against the brightness, you're actually watching millions of tiny crystal surfaces acting like a giant mirror array, bouncing the entire spectrum of sunlight back at your eyes simultaneously. But here comes the part nobody sees. The whiteness of snow is not about the water at all. It's about the air. Those gaps between crystals, the tiny pockets of nothing between one flake and the next, are where the real action is. Every time light crosses the boundary between ice and air, it bends and scatters. Remove those air pockets and you're left with a solid block of ice, transparent again. Compress snow hard enough and long enough, the way glaciers form over centuries, and the weight squeezes out the air. The crystals fuse, the boundaries disappear, and the ice goes clear, sometimes with a deep blue tint, because the dense ice absorbs the red end of the spectrum slightly more than the blue. The result? The same water molecule in one form creates a surface that reflects nearly 90% of incoming sunlight back into space, one of the highest reflectivity rates of any natural material on Earth. Snow is so good at reflecting sunlight that scientists measure it as a key variable in global climate models. A world with more snow cover is measurably cooler. A world losing snow cover absorbs more heat. The difference between a snowy field and a bare, dark field in terms of energy absorption is roughly the same as painting a city black. If you're finding this fascinating, hit that like button and subscribe to The Curious Mechanism for more hidden physics stories. But you're probably thinking, okay, but what about dirty snow? Why does it turn gray and then dark almost immediately once it gets old? The system isn't dumb. Fresh snow's whiteness depends entirely on clean, intact crystal boundaries and those tiny air pockets. The moment particles, dust, soot, pollution, even microscopic algae settle into those gaps, they start absorbing specific wavelengths instead of reflecting everything equally. The crystal structure also degrades over time. Sharp edges round off, crystals merge, air pockets close. The snow isn't just getting dirty, it's structurally aging, losing the exact architecture that made it white in the first place. Now comes the invisible part, the real engineering. Only here, nature built it over billions of years. A single snowflake is only white in bulk, not alone. One crystal in your hand is nearly transparent. Two crystals side by side start scattering slightly. 1,000 packed together, and suddenly you have a surface bright enough to cause snow blindness. The whiteness is a collective property. It doesn't exist in any single piece. It only emerges when billions of ice boundaries stack up in the right configuration. No single flake is white. The whiteness belongs to the system. And here's an uncomfortable truth. This invisible physics has civilizational consequences. Arctic and Antarctic ice sheets act as the planet's thermostat. Their near-perfect reflectivity sends enormous amounts of solar energy back into space before it can warm the surface. Remove that reflective layer, replace white ice with dark ocean water, and the same sunlight that was bouncing harmlessly back into space suddenly gets absorbed. The feedback loop is brutal. Less ice means more warming, which means less ice. Scientists call it ice albedo feedback. It's one of the most powerful self-reinforcing cycles in Earth's climate system, and it runs entirely on the difference between a clear surface and a white one. We forget that because snow just looks like winter. So next time you step outside after a snowstorm and shield your eyes against that almost painful brightness, remember you're not just seeing frozen water. You're seeing billions of tiny air pockets and crystal boundaries conspiring to throw the entire visible spectrum back at you at once, a collective optical illusion so powerful it helps regulate the temperature of the planet. One molecule, two forms, two completely different relationships with light, and the difference between them is mostly just air. If this changed the way you see a snowy morning, subscribe to The Curious Mechanism and hit the like button. Share this with someone who never thought there was a reason snow looks the way it does. This is The Curious Mechanism, exploring the invisible systems that keep the world running.